little bit different than the SAS, which we did, before the weekend. And this is why, even if you mess up the order of things, sometimes it works, because this theorem also works. And I broke this down instead of doing sometimes it's harder for me to look at the RT over TQs. And so I broke this down more of an algebra expression. And so basically what this is it is x over y is equal to a over b. Okay. Now you will see me when I go over a problem that I will do this. And I'll do this a lot. I do it every year because of the way I think of things. I do x over a and y over b. Is that wrong? How come? Will still be equal. Because when you cross multiply, you're going to get ay equals bx. And this is also going to be ay equals bx, right? So just be aware there's just a lot of ways to do these, and it depends on how you see them. And of course, we could also do the SAS, where we do y over x plus y. We could do b over a plus b. So really the goal is for you to use the easiest way for you to solve the problem. Okay, moving on to the next one. Of course, the converse, if this proportion works, that means that these are parallel. Of course, if these aren't parallel, then it doesn't work. They have to be parallel. So this is just like what we just did, except for it doesn't quite make a triangle, does it? What would happen if these lines continued? It'd be a triangle, wouldn't it? And so this is what you want to see. This is what the next theorem states. It states that x over a, I'm sorry, let me do the way that they want me to do it. It states that x over y equals a over b. Okay, and I put this extra thing, z and c. That's not actually in your theorem. But you could also do these things. You could do x over z equals a over c. So I could do the short line over the big line equals the short line over the big line. Okay? Does that make some sense? Because basically you can add line segments all day long. So this is something good to know. All right, the last one's a little weird, and there's going to be a hard problem with it as well. So let's go over the last theorem here. I guess I need to switch room. So this is the triangle bisector theorem. And again, I'm going to break this down kind of in an algebra way rather than how it's written in the book. That's why I have you copy it first so you can try to see what it means, and then I'm going to break it down. So I didn't quite draw this correctly, but let's call this, these are equal, and I'm going to call this x, and this y, and I'm going to call this a, and this b. Okay, so I'm going to do x over y equals a over b. Again, so this is how I look at this. See how this is one triangle here? When I draw that, and this is the other triangle, they're similar. And so the ratios should be the same. See how x and y are from the same triangle, and a or b are from the other triangle. Okay? So that's basically it. So let's go ahead and look at number 3. Number 3. And this would be on page 406. And go ahead and read it. I think that this is what it means. Okay, it says to find AB. I put X for AB because I'm supposed to find this. And I labeled the rest of it, right? So what do we do? Is that just X over 3 equals 12 over 4? That's 4x equals 36. X would equal 9, right? Is that right? Did I do that? Okay. Okay, that's not bad. All right, let's look at 5. We're doing the converse with 5, and so they give us stuff. They give us this information, and we're trying to determine, are those lines parallel? Well, let me move this. The way to determine if those lines are parallel, these lines right here, bam, bam, is if we, if they're in proportion. So I'm just supposed to do this. 8 over 5 equals 12 over 7.5. If this is true, then the lines are parallel. And one easy way to figure out if the two ratios are equal and form a proportion, we just cross multiply. And so we just do 8 times 7.5. There's a point there. What is that, 60? Was that right? So 8 times 7.5 is 60. What is 5 times 12? So that means that the left equals the right. That means that both of these ratios are congruent. They form a proportion, which means, yes, those lines are parallel. Does that make sense? All right, moving on to, we're skipping the ruler stuff. Skipping on to 13. 13's that technical geometry stuff. So let's see if we can translate this to make it work. I'll do some lines here. That's close enough. And FDB, GEC. All right. So here's what we need to know. BD, that's right here. That line over BF. BF is this line, right? So that means that I should do the equivalent. I should do this over this. So what's missing? I got BD over BF. And I think I heard the right answer. I heard CE over CG. Is that right? Okay, so that's right. You see how that works, where we can take the full line and the short line? It works. This is really useful when you do various technical art projects. Okay, moving on down the road. Well, might as well do 19. And we're going to do 21 as well. All right, here's 19. All right, we do that. 16.5, sure, why not? Not 165. This is P. I guess I'm trying to find that. That's 11. This is 29. All right. So we're going to have to do 16.5 over 11. And P over, well, I can't do 29. I need to know what this is right here. What's that? Is it 18? Okay. That's how I set that up. Okay, I will let you work that out. But I want to skip down to 22 because 22 is on your assignment. 22 is kind of hard. And so I'm going to fill in some information that is useful to you, not just right now, but in the future as well. They give us 36. They gave us 28. They give us Q. And they give us 16. How in the world am I supposed to figure out what this line is right here? Don't I need that? Okay, and this is what I'm going to tell you. I don't know what this is, but I know what this plus this equals 16, right? So I'm going to call this 16 minus Q. Because 16 minus Q plus Q, what does that equal? 16. So you can do the work doing that. That's your hint on 22. Your assignment is going to be